Okay, section 4.5, graphing sine and cosine. So there's some definitions at the top. A maximum is a point where the graph's y values are increasing and then decreasing. So the values are going up, and then they're going down. The maximum is the top of a hill. That's how we'll probably talk about it in class. The maximum is the top of a hill. A minimum is where the graph's points, the point where the graph's y values are decreasing and then increasing. So it's going down and then it turns and it starts going up. So a minimum is the bottom of a valley. We are dealing with relative mins and maxes, just like we did for polynomials. This shouldn't be new for you. Remember definition of odd and even also written there. Odd is when you plug in a negative x and you just get the same answer back out. You get the opposite answer back out. Even is when you plug in a negative x and you get the same answer back out. We like to talk about it in class. Odd, you can flip it over and it's the same. Even, you can fold it on the y-axis and it's the same. Okay, so graphing sine, we are going to do this in radians. So if you went around the unit circle, if you went around the unit circle counterclockwise, you would start at 0, and remember sine is the y value, that's why the y value is 0. Then at pi over 4, sine is the y value is root 2 over 2. Once you get up to pi, the y value is 1. Once you get to 3 pi over 4, etc. So you're going around, once you get down here to 5 pi over 4, the answers start becoming negative. You're going around the unit circle and you're measuring the y value, right? The distance to the x-axis is what all these points represent as you go around the unit circle. If you plot those, you get the graph on the right-hand side. So there's a couple important things we want to focus on. The period is one full cycle, right? You'll notice that the sine curve goes up, and then it goes down, and then it comes back up. That's one full cycle, one hill and one valley. The period for the parent graph of sine is 2 pi units, the horizontal length of one full pattern. Amplitude is the height of a hill. So distance from, we're going to talk about this midline in a second, to the top of a hill is your amplitude. For parent graph of sine, it is 1. And then sine goes from 0 to 2 pi. Okay. When we go to start graphing this, we are going to start with a green line on the midline. So right here is the middle of sine. That's called the midline. That's going to be the first thing we graph in class. Then notice for sine, there are 3 points. This is going to be called the beginning point. Way over here, this is going to be called the end point. And then right in the middle, guess what that's going to be called? The middle point. All 3 of those, beginning, middle, and end, for sine, land on the midline, that green line. So the first thing we're going to do is plot the beginning. We're going to figure out how long the period is, then we're going to plot the end. Then we're going to find the middle of that and plot the middle all on that green line. Then for sine, between middle and beginning, you find the middle of that, and you instantly do the amplitude. You go up A. Between middle and end, you find the middle of that, and you do opposite A. You go down whatever A is. That'll be your 5th point, and you're going to try to graph it to look like a sine curve. It looks like a wave, right? It's not pointy. It looks like a wave curve. For our formula down here, let me color code this the way I plan to in class. Oh, I want to make a note. Amplitude is always positive. You will have answer blanks that ask you for an amplitude. It doesn't matter what A is, amplitude is a length, so amplitude is always positive. So here we're going to highlight in that same light pink color that A is your amplitude, but you always give me the positive answer. Then to find the period, which was yellow earlier, you always do 2 pi divided by that b value. C is your left-right phase shift. For phase shift, remember it's in parentheses. Phase means left-right. And it's always opposite what you think it's going to be. Just like when we did vertex of a parabola and everything else. And then that green line, so I'm purposely making this green, that will move with D. That's your vertical shift, your up-down. So we're going to put all of this together and graph some sine curves. Here we go. Okay, we're going to find all that stuff. First, we make sure it's in graphing notation. Let me go back over here. Our graphing form, I talked about this a lot when we were doing other transformation graphs. Notice, I'm just going to use purple for a second. I'm going to erase it. This is always a single positive x. And if there's a b value, you need to factor it out front. Just like we did for transformations, this isn't new. Okay, so this one, I can see it is a single positive x in that spot right here. So there's nothing I need to factor out. And we're ready to start figuring things out. So let's color code this. A gives me the amplitude. Amplitude is always positive. Coincidentally, that number is positive also. So amplitude is 2. There's no negative. A is not negative. So there's no vertical reflection, just like parabolas and everything else, every other parent graph we've done. The period is going to be 2 pi divided by, there's an imaginary bracket with a 1 right there. We were making that yellow. So it's imaginary, but it is there. So 2 pi divided by 1, which is just 2 pi. Phase shift comes out of the parentheses. So you're going to do opposite. Opposite of minus pi means it's going to go to the right pi. And then my vertical shift is going to be, there's imaginary plus 0 at the end of this. So it has no vertical shift, none. Okay, so here's what we want. We want to know, where is my beginning point? These are answer blanks you have to draw for write for yourself, because they're not worth points, but they're going to be how you get the graph. So that beginning point is always, we should add it right here. It's wherever your phase lands. So since my phase is right pi, when you go to the right on the x-axis, that's positive pi. So my beginning point is going to be on pi on the green line. That came from the orange one. My end is always that answer, the beginning answer. Let's write this down here. Beginning and then plus the period. So it's that answer pi plus, and earlier we got an answer of 2 pi for the period. So it's going to end at 3 pi. So it's that orange plus the answer to yellow gives you the end. You're going to need to start setting up your own axes for these things. So let's look at my numbers. I know it's going to start at pi and go to 3 pi, so it's going to be pretty far to the right. And I know it has no vertical shift. It's not going to go up or down. So it's going to all be on the right-hand side, so I can draw my y-axis pretty close to the border. And then center my x-axis. You need to make your tick marks count the same as your beginning and end. So my beginning is pi, my end is 3 pi. So I can start by making ticks of pi. There's obviously a lot of things between 0 and pi, so leave a little bit of space. But this one can be pi. Try to use the same amount of space. This can be 2 pi. This one would be 3 pi. The y-axis, we're always going to count by ones. Okay, to start, you draw that green line that I mentioned before. So this has no phase shift. So my green line is going to be right on the x-axis. It's dotted because it's imaginary. I'm kind of going off my x-axis so you can see it. It's dotted because it's imaginary because it's just to help us get the graph. This is a sine graph. We're going to learn more in the future, obviously. Sine, the beginning and end are on the green line. So my answer blank on the left says beginning at pi. So at pi, there's a point on the green line. My end says 3 pi. At 3 pi, there's a point on the green line. And then we know from the page before, the middle of sine is also on the green line. I can clearly see the middle of pi and 3 pi is 2 pi. That is on the green line as well. Now we need to find the middle of those segments. So between beginning and middle, there's a center. That's going to be 3 pi over 2. Add and divide by 2. Between these two, there's a center. That's 5 pi and divide by 2. 5 pi over 2. For sine, the first segment, when you cut that in half, that instantly does a. So a is positive 2, so I'm going to go up 2. The other side does opposite a, so I'm going to go down 2. This is my sine curve. It's important to know that it continues on forever. It keeps doing, don't write that, it keeps doing the same thing in both directions, but we're only going to graph one period of sine so that we can see everything we need to see. Okay, then there's a bunch of other things we need to find. We need to find the domain, the range, relative minimum, relative maximum, the y-intercept. Is this even, odd, or neither? And asymptotes. Okay, so domain. Remember, we graphed one period, one cycle of pi, but it does go on forever, so the domain is all real numbers. Range, what's the lowest this graph goes? Well, it goes down to -2 and it touches it, so that's a bracket. What's the highest this graph goes? It goes up to +2 and it touches that. That's a bracket as well. Relative minimum, the low point of a valley. That point is at 5 pi over 2, but this is just one cycle of sine. It repeats every 2 pi n, so it repeats plus or minus 2 pi n, and then the y value is -2. Relative minimum is a point. So this is saying it's going to be at 5 pi over 2, it's going to be at 9 pi over 2, it's going to be at pi over 2, it's going to repeat every 2 pi n, right? Because this curve keeps doing that. So there'll be another one here, and then later there'll be another one there, etc. So you have to include that in your answer for relative minimum or it will be marked wrong. Relative maximum, the peak of a hill, that is located at 3 pi over 2, and it repeats every period as well, plus or minus 2 pi n, and its value is +2. Y-intercept. So we're pretty far from the y-axis, but you should be able to look at it and figure out what's going to happen, right? So don't do this. I'm going to erase this in a second. This distance backwards is the same as this distance forwards. But actually, we should go backwards, right? We're at this point here, and we go backwards this same distance. It should land on 0. But sometimes that's hard to see. So don't forget Algebra 1 skills, right? Y-intercept. Let's go over here. Plug in 0 for x. So y is going to be 2 sine of -pi plus 0. I don't need that. So this is where your unit circle comes in, right? At -pi, that's here, what's the sine value? Well, the sine value is 0. And 2 times 0 is 0, which I had estimated just by looking at the graph, but now we've done it algebraically. If let's fill that in. Graph hits at 0, and then it's going to continue on that way. If you flip this upside down, it is going to be identical. So this one is odd. And then asymptotes. Sine graphs don't have any asymptotes. Okay, let's see what's next. Okay, this one is not in graphing form. So we need to put this one in graphing form before we go any further. So we've got negative sine, that's fine. we need a single positive x in this spot. Minus 2 is fine. So clearly we need the factor of the 3 out front. When you divide by 3, if you're already dividing by 2, it becomes pi over 6. So if you need to see that, pi over 2 divided by 3 is the same thing as pi over 2 times 1/3. And when you multiply 2 times 3, you get 6. So now it's in graphing form. Now we can highlight things. So amplitude's going to come from that. That was wrong. Amplitude's going to come from the front. We're going to use that to find the period. Phase shift is in there. Midline and vertical shift is at the end. So let's match these up. That pink number answers both of these. Okay, so amplitude. A is -1, but amplitude is always positive because it's a height. The height of the hill is +1. But yes, there's a vertical reflection because it is negative. Period is 2 pi over that B number. Since it doesn't reduce, we'll just leave it like that. Phase shift, it says plus pi over 6. You know that's going to move it left pi over 6. And -2 is down 2. So beginning, middle, and end. Well, beginning and end. We'll just put the middle on the graph itself. So if it's left pi over 6, it's going to begin at negative pi over 6. So beginning needs to be in number form. A phase shift is a direction. And that answer plus the period. So common denominator, you might need to do some math here, times 2 times 2. Plus 4 pi over 6 is going to be 3 pi over 6, which I understand reduces to pi over 2, but you don't want to reduce it. That is not going to help you in the end. So we're going to start at negative pi over 6, so we need a little bit of space on the negatives. And the whole thing is shifted down too, so probably put your x-axis up a little bit. It is counting by sixths, so my phase is in sixth, my end is in sixth, so I want to count by sixth. Negative pi over 6. 1, 6, 2, 6, 3, 6 is where it ends, so that's as far as I need to go. Okay, my green line, my midline, is down 2. I'm on graph paper, so I wasn't going to put the tick marks, but we should put the tick marks to see. So I'm down 2 for my midline. And I am graphing sine. For sine, the beginning point, so I'm looking over here, right? Negative pi over 6 is on the midline. So I put a red dot at negative pi over 6 on the green line. The end, 3 pi over 6, is also on the midline. And the middle of that, you can count it out or you can do the math. The middle is also on the green line. Then my first segment, and I'm left segment, instantly does A. Remember, A is -1, so I'm instantly going to go down 1. And my second segment does the opposite, so up 1. This is my sine curve. Okay, I added some answer blanks. Pause the video to copy those down. Pause the video and see what ones you can answer on your own. Remember, we graphed 1 cycle of sine, but it does continue forever. So domain is all real numbers. Range, the lowest I see my graph going is -3. The highest I see it going is -1. And it is touching those, so brackets. Relative minimum is a point, the lowest point, but remember it repeats forever. Relative max is the highest point, remember it repeats forever. So my minimum is clearly at 0, but it repeats every period. So it's not always 2 pi n, right? This one repeats every 2 pi over 3 n. Make sure your n is next to that fraction. And then it's at -3. It's a point. I'm writing a point. Technically, I'm writing infinite number of points, but it's always parentheses for mins and max, and that number came from my period. Relative maximum, I was counting by 6. 1, 6, 2 sixths. You're welcome to reduce that. You might have to reduce it if it's multiple choice, right? but it repeats every period, and the y value is -1. I got lucky, my y-intercept is a point on my graph. If I flip this upside down, instead of being down 2, it's going to be up 2. And it does, so it's not odd is what I was saying. But if I continue this, hopefully you can see that if you fold it on the y-axis, this is going to match up. So this one is an example of even. So if you continued your sine curve and you fold it on the y-axis, everything lands on itself, so it ends up being even. The asymptote does not exist. Okay, so moving on to graphing cosine. As you go around the unit circle, you start at 0. The cosine value there is the x value, right? So that's why the y value is 1. As you go around, for example, you get to pi over 4. The x value is √2/2. At pi over 2, the x value is 0. And then they start to go negative as you go around, because remember we are measuring the x values, because cosine is the x value as you go around the unit circle. And that's where all these numbers come from. Cosine has a lot of things in common with sine. One of them is that the period is still going to be 2 pi for the parent graph. And then we still are going to have that green line representing our midline. And for the parent graph, it is on the x-axis. But here is one of the huge differences. Cosine instantly does A from the midline at the beginning. So now your beginning point is going to be A from the midline, and then notice your end point matches. Your end point is also A from the midline. Then if you find the middle of that, you go opposite A. To get the middle point. And then when you cut those segments in half, those points are on the green line. This is the pattern that the cosine graph has. We are going to work on finding everything the same way. So example, the period is still 2 pi over b. Amplitude is still always positive. And beginning plus period is still going to equal the end, so that we know the x value for our end of cosine. So let's jump into an example. I guess I can highlight this stuff for you again, right? B is there, C the phase shift, D the midline, the green line, the vertical shift, and then A is in the front. Okay, so again, it needs to be in graphing form. Right away, you should notice that this one is not, because you need it to say, it says a half, write it down the way it's written, bracket, parentheses, single positive x, and then that means you have to factor the 4 out front. Factoring is the same thing as dividing, so now this is pi over 4. Double check, 4 times pi over 4 does give you pi, so I know I got it right. So that's my graphing form, and that's where I'm going to highlight all the numbers that do different things. Okay, so the amplitude is positive because it's a height. The 1/3 in front is the amplitude. Since it already is positive in the equation, there's no vertical reflection. The period is 2 pi over 4, which I guess for now we'll reduce, but we'll see if maybe we should have left that non-reduced at the end. So pi over 2. Actually, well, I'm going to do it because I said I was going to do it. Okay. The phase shift, it says minus pi over 4, so that means, remember, we are looking here in the parentheses to get the phase shift. I didn't finish coloring these. In our graphing form is what I want you to notice. So minus is actually going to move it to the right, pi over 4. Vertical shift is down 1. So I need to find my beginning and my end, and then I need to treat them differently because we are graphing cosine now. So if it went right pi over 4, that's positive pi over 4. That still comes from your phase shift. The end is going to be that number plus the period. See, this is why I should have left it. I'm going to go back to the non-reduced form, because in non-reduced form, the denominators match. So now I can easily add those together. Okay, so setting up our x's, it's right pi over 4 and down 1. So my y-axis can be pretty close, and I am going to go down, so leave a little room up above. Everything's in pi over 4s. My non-reduced period is 2 pi over 4. Beginning is pi over 4, and end is 3 pi over 4, so it doesn't go very far, so I might as well make a pretty big gap. Call that pi over 4. This would be 2 pi over 4, and this would be 3 pi over 4. By 1s on your y-axis, and then we start with the midline, down 1. So this is going to be my midline. Everything is going to happen from there. So beginning says pi over 4. So I put my pencil at pi over 4 on the green line. But then since I'm doing cosine, I instantly do a. A is positive a third, so I'm going to go up a third. It's going to be approximate, right, because it's a fraction. My end is 3 pi over 4, and I do the same thing, up a third. I can see the middle of that is the 2 pi over 4, down a third. Then the middle of those pieces are on the green line. For cosine, those middle of the segments are on the green line. And it's a very compressed cosine that missed. It's not very tall at all. It's been compressed vertically. Okay, so I filled in the answer blanks. Pause the video and write your answer blanks if you need to, and then see how many of them you can answer on your own. So domain, remember this is one cycle, but it does continue on forever, just like sine. And the thing is, if I continue this on forever, now you can't even tell if it was a sine or a cosine graph, which is part of why we only graph one cycle. When we graph them infinitely, it's really hard to tell sine from cosine, which is why if you have an infinite one graphed in front of you, there's technically an infinite number of equations that could get that graph. So domain, it goes on forever, all real numbers. Range, it went a third below 1, so negative 1 and a third, all the way up to a third above negative 1, which is actually negative 2/3. Then relative min, relative max. I've been making minimum blue. Bottom of a valley. Max is purple. I always just choose the furthest to the left value. So bottom of a valley. It's perfectly fine if you leave it in this form for free response, but don't forget multiple choice, you might have to reduce. And it repeats every period. And in this case, the period is pi over 2, and then you put the n at the end, comma. That's the x value. It's a point. The y value is negative 1 and a third. Relative max happens at pi over 4, but it repeats every pi over 2n. Remember, that's coming from the period, and it also would be okay if you don't use the reduced form there. And its value is negative 2/3. Y-intercept, even on neither asymptote. Asymptote does not exist. Maybe you can figure out the y-intercept by looking at your graph, but just in case you can't, don't forget you can always fall back on math. Plug 0 into the original equation. And I'm using the original at the top without graphing form because it makes it nice. That all goes away and I just have negative pi left. So negative pi is here. Cosine of that is negative 1. Oops, 1/3. Cosine of negative pi is negative 1 minus 1. So this is negative 1/3 minus 1. So the y-intercept does happen to be our minimum, relative minimum. So 0, comma, negative 1 and a third. When that happens, when your y-intercept is a min or a max, this ends up being an even graph. Because if I, let's see, come back, I'm not going to be able to graph that well. And my minimum is on the y-axis. Hopefully you can see or at least understand that it would fold on itself if you fold on the y-axis, and that makes it even. And I already said the asymptote does not exist. Okay, last one. So they graph these data points. Feel free to read the paragraph explaining it to yourself, but technically I don't need that paragraph to answer it since there is a graph. I can see the midline is right here, which happens to be at 0. And then I should be able to figure out the A value, the distance from the midline to the top. I can see that A equals 65. And then the period from beginning to end, the period, I hope you guys can see that yellow font, it goes from 0 to 40. So remember, period equals 2 pi divided by b. So we know 40 equals 2 pi divided by b, and we need to solve for b. Cross multiply or multiply by b. Solve for b. Reduce, I guess. B must be pi over 20 in order to get a period that is 40. So here we go. What are the period, amplitude, and equation of the sine wave? So clearly it's sine. Period, I answered those here, right? You guys good with this? Period is 40, amplitude is 65. Equation. Don't forget y equals. It's not an equation without y or f of x. A is going to be 65, and it is positive because the sine curve does go up first. And then sine, bracket, parentheses, x. So because the beginning point is at 0, there will not be anything in this parentheses with the x. There's no phase shift. Bracket. And then because the midline is at 0, there is also no vertical shift. So we just need to put that pi over 20 in front of x because that needs to be our b value. Use the equation to estimate the change in line of sight velocity on day 36. So plug in 36. I would assume you would need to use a calculator here, or you could stop here. If you were going to use a calculator, whenever you see the pi symbol, that means you need to be in radian mode. We won't do this much, so I don't want you guys to panic. But if you did type that into your calculator in the correct mode, it would give you negative 38.206. Okay, so that is it for sine and cosine. I hope you guys are doing good.